Hello everyone, today we shall discuss chapter Motion in a Straight Line. The question number is 2.15. Suggest a suitable physical situation for each of the following graphs. Number 1, you see here the graph is like this. You see the graph, if you read this graph you will find the graph is like this. That is from this is the rest position, then it increases with time fixed point, then decreases to 0 and then goes in the opposite direction, that is -6. Then it has a it has the then it is constant in the straight line, right? So you can explain this in this way, that solution number A, that getting solution number A, you see here, that is solution of A. How we are finding? They gives the given graph, the given graph, that xt position time graph shows that initially a body was at rest, see this position, right, at rest. Then its velocity increases, then its velocity increases, with time, and attains an instantaneous constant value. The velocity then decreases. The velocity then decreases. The velocity then decreases to 0 with an increase in time. Then its velocity increases with time, then its velocity increases with time in opposite direction and acquires a constant value, acquires a constant value a similar physical situation arises when a football initially kept at rest initially kept at rest is kicked and ultimately gets stopped, and ultimately and ultimately and ultimately ultimately gets stopped after some time, right? And number b can be written as in this way, that this is the equation, this is the suitable velocity. What is that? That in the vt graph, in the given vt graph, even vt graph, the sign of velocity changes. The sign of velocity changes. Sign of velocity changes, and its magnitude and its magnitude and its magnitude and its magnitude decreases decreases magnitude decreases with a passage of time, with passage of time. A similar situation arises. A similar situation arises when a similar situation arises when a ball is dropped. Ball is dropped on the hard floor, on the hard floor, the hard floor, on the hard floor from a height, from a height. It strikes the floor. It strikes the floor. It strikes the floor. It strikes the floor with some velocity, with some velocity, and upon rebound and upon rebound and upon rebound its velocity decreases. Its velocity decreases by factor, decreases by a factor. This continues till the velocity of the ball till the velocity of the ball eventually becomes zero. This is the case of B, right? This here, in this here, the velocity is decreasing with passage of time, and the velocity becomes zero, right? And in section C, you will find it here as, in section C, if we find this one, in section C, let us find what is the graph shows us. In section C, you will find it here as that. You can see the graph and find it in this way that this is the C part, and C part in found can be found out in this way that in C, in the given graph, in the given acceleration time graph, acceleration time graph reveals that initially the body is moving, the body is moving what is moving with initially the body is moving with a certain uniform velocity, uniform velocity certain uniform velocity it accelerates, its acceleration increases, its acceleration increases, the acceleration increases for a short interval of time, for a short interval of time, short interval of time, which again drops to zero, which again drops to zero. This indicates that the body again starts moving, that the body again starts moving indicate that the body again starts moving with the same constant velocity, with the same constant velocity, same constant velocity. A similar physical situation arises. A similar physical situation arises. Physical situation arises when a hammer moving with uniform velocity strikes a nail. Thank you everybody for watching this video.